Welcome all to the second presentation of the day. And before I introduce our next lecturer, I would like to inform the people that are joining us for the first time that you may ask written questions during the talk by using the function Q&A that is available in the bar at the bottom of the screen. Those questions will be both voted by the audience at the end of the lecture and answered afterwards by the presenter. And now I have the pleasure to introduce Dr. Michael Dähne of the German Oceanographic Museum that will talk about porpoises, conservation from science to regulation, basic principles illustrated by German wind farm developments. Michael, the floor is yours. Thank you very much for joining us.
Well, thank you, Luis, very much for the introduction. And working at a museum, it is a pleasure for me to also show the nice graphic work that our illustrators are actually doing, and that brings science really close to people. So today, the topic is porpoise conservation from science to regulation. And I'm going to talk about the North Sea, as Jakob did as well. And just to give you a brief introduction about how it changed over time. So in 2008, that was the map of how ship traffic was actually going through the North Sea. And that hasn't much changed until now. It's even increasing a bit. Then you have the usage for oil and gas production. And as you can see, even though the gross production goes down, the actual total number of installations is increasing or was increasing until 2007. And then there were actually plans to build wave power and other power installations, also wind farms. And Jakob has already shown that map a little bit, and I'm going to walk you through it a little bit more. So actually the blue spots down here are consulting areas. So these are areas where future wind farms will be built. There are some things that are in the concept or early planning phase, so a little bit advanced. And then there are authorized wind farms. We have pre-construction wind farms. And then we have the ones that are realized in green. And if I increase that a little bit more, then you can see that in Germany, actually, quite a lot of wind farms have already been built. They are much smaller than other wind farms plannings in Europe. And I will go a little bit into detail why this is actually the case. So I'm going to talk today mainly about the precautionary principle and putting it into legislation, because I think that the German wind farm development is a very good example for it. The precautionary principle or precautionary approach is a broad epistemological, philosophical, and legal approach to innovations with potential for causing harm when extensive scientific knowledge on the matter is lacking. And that is mainly where biologists are all the time through. But it's not only biologists that are there, it's engineers who are there because they implement a factor of safety, and that is an implementation of the precautionary principle. Actually, we go through a pandemic right now, and the shutdown and lockdown that we are going through is a precautionary principle implementation. And then you have implementations for food safety and a lot of other things that go through. It comes from the German Vorsorgeprinzip and was implemented for the first time in protecting forest degradation and sea pollution in 1970. I want to remind you all that in the Rio Declaration in 1992, this is what is written down there. In cases when you have irreversible damage, lack of full scientific certainty shall not be used as a reason for postponing cost-effective measures for preventing environmental degradation. And there are a number of things that you have to consider if you want to implement this principle of precaution. You need to have standards that are up and updated. You need to have thresholds for certain impacts. You need to have a monitoring and enforcement in place. And then you have also the need for mitigation concepts to actually make it work. So I'm going to walk you through how the things got together in Germany. So the first bubble curtain was actually tested in Hong Kong in 1996. Its attenuation was 3 to 5 dB, and while that doesn't seem to be a very good attenuation efficiency, it was actually showing that the principle of just laying down a hose on the bottom with holes in it and pushing through air is actually working to attenuate noise that is implemented into the nature by pile driving. It didn't work well where the piling barge was situated. It was working much better perpendicular to the bubble curtain. In 2003, the German Maritime, Federal Maritime Agency was putting out the first Stuck, which is the standard for environmental impact assessments. And it describes in detail what shall be done if you want to build a wind farm, which environmental precautions you have to take. And this was updated throughout time in 2007 to version 3, and then in 2013 to its actual version, the Stuck 4. So this is part of the standards part. And in there, it is also written that not more than 80 generators shall be installed per wind farm. And that is the reason why we have only smaller wind farms in Germany. In 2005 and 2006, Klaus Lucke tested for the first time whether porpoises are susceptible to a temporary threshold shift, and you can term that to be the onset of injury in mammals due to noise effects. He found that there is a temporary threshold shift of exposing the animals to a seismic air gun at about 200 dB peak to peak and an SEL of 164 dB Ray1 microscope. This was actually the first scientific evidence that impulsive sounds can injure porpoises temporarily. And now we go back to the precautionary principle, and you have now, first of all, an indication that there is a risk for harm. You do have standards in place to make that happen, and you do have something which you could deem can be effective in terms of mitigation, which is the bubble curtain. So then the agencies in Germany, actually the nature protection agencies, talked about a limit, and that was called a precautionary threshold value or precautionary value. They proposed this limit in 2007 for the first time, shortly after Klaus Lucke did his trials, with a level peak to peak of 190 dB Ray1 micropascal and an SEL of 160 dB Ray1 micropascal squared second. And this was supposed to be held in 750 meters distance from piling. And while this is only for the reason that you cannot observe porpoises in further distances, I do think it's a practical value that was decided upon. So in 2008, we have then the building of the Alpha Ventus wind farm. It was only 12 generators built with different methodologies. There were aerial surveys and acoustic monitoring conducted. And here you can see a picture how the porpoises were distributed before the pile driving took place. And then during an exceptionally long pile driving, where you clearly see an avoidance of the porpoises around the wind farm, which is in the middle here. So the results were that there is a 20 kilometers disturbance radius and about 17 hours duration of this. And the limit of 160 dB that was proposed before was not reached, even though already at that wind farm, the first bubble curtains were tested for their mitigation efficiency. And they showed some potential with keeping the limit just on the brink. And so it was decided that the route was actually a good one. So the Federal Maritime Agency, the BSH, was then implementing the precautionary value within each licensing for further offshore wind farms. And it was stipulated that the wind farm providers shall abide the rules of what I said before. This is a very important step because it means that the polluter pays. It means that actually wind farm developers pay for whatever they are putting out there. It also means that you are enabled to do a compliance monitoring. You can put a hydrophone in the water and it will show you whether you keep the value. And this enables then the enforcement of keeping to the rules. And it will also enable you to do mitigation if the values are not kept towards a standard. So this is a critical point of view and a critical step within the whole process. So if we go through an example, what you can do in terms of avoiding mitigation or avoiding exposure of porpoises towards sound, then you can avoid the exposure while doing pile driving in times of low abundance. You can avoid noisy procedures. You can alter the emitted sound using alternative piling hammers or using noise mitigation systems, and even different pile materials, or you can displace the animals prior to pile driving using pingers, seals, scarers, fauna guard, and the other methodologies. But the cost of these different things is very high towards the left-hand side of that plot and much lighter to the right-hand side. While the efficacy to protect animals from injury is good for the two alternatives on the right-hand side, but it gets worse for the ones on the left-hand side. And then there's the efficacy to protect animals from disturbance, and actually that increases for pingers, seals, scarers, and fauna guard, so it's not a good alternative. And then there's the willingness to actually implement the mitigation, which I call the acceptance, and that is, of course, tightly coupled to the costs of the mitigation measure. But you then have to come to a point where you either limit the exposure or you limit, for instance, the number of animals exposed and disturbed to the sound using the models that Jakob has described. But the BSH was rather going for limiting the thresholds. So that actually sparked a number of developments. The wind farm producers produced, for instance, suction buckets, as outlined here. There was the proposal of doing different hammer technologies. So this is an explosion-driven, water-driven hammer by blue piling. Then you have different noise mitigation screens that were developed, for instance, by IHC. And then you had a lot of developments in terms of what is going on with the coupling of the sediment and the water. Why actually mitigations that are employed close to the pile do not work in further distance that well. So it sparked a lot of different developments. And this is very crucial because it was coming from the threshold that was set. So in 2013, the Dantusk wind farm was built, and actually 2 mitigation measures were employed there, or 3 actually. So there was a seal scarer employed to drive the porpoises away prior to pile driving. There was mitigation measures installed in terms of 2 large bubble curtains as well. And we recorded during that time, as Jakob already a little bit outlined, all of these recordings. And I'm going to walk you through how actually the sound is. And I hope you can all hear it. And I'm going to play you first in very close distance to pile driving. I do not hear the sound, so I hope I fit the time right. I'm going to play you back sound in further distance from pile driving, so in 14 to 60 kilometers distance. And then I do see there's a chat coming up. I hope it's working. Yes, it's working. Nice. And then I'm going to play you the sound in 4.5 kilometers distance. Attenuated was a bubble curtain. And with another kind of bubble curtain. And with both combined. And as you can hear, the high frequency component of the sound is actually reduced very much, and we could show that it is actually not there anymore in 16 kilometers distance. It's not above background noise anymore, and that means that porpoises may not hear this, actually for them more interesting sounds. And I'm going to walk you through the displacement as well. So you have a time prior to pile driving, which we call the baseline. You have the time when the seal scarrow was there to displace porpoises intentionally. Then you have the pile driving period itself, and then the time afterwards where actually it goes back. And you can see in 1.5 to 3 kilometers distance, you have a clear effect. The seal scarrow and the pile driving reduce the number of porpoises that are being registered. If we move further away, 3.6 kilometers is still there. You can see that in 6 to 9 kilometers distance and 9 to 12 kilometers distance. And the seal scarrow in that case is still as effective in displacement as piling. While in 12 to 15 kilometers, the effect is pretty much gone. So this has to be taken into account when you build up a noise mitigation concept, of course. In 2013, pretty much at the same time when Ventus was built, the German Bundestag adopted the noise mitigation concept as a public law. And that gave planning safety to the wind farm constructors, because when they abided by the rules, they could actually build. So there was no ambiguity in interpreting the law. It also included some models for disturbance, and it actually said that at 140 dB real µPa² SEL, porpoises would be deterred from the wind farms. It is in no case perfect, but it is a pretty good guidance document that you can use and that you can work by. And since then, there have been a lot of new results and outlooks. So for instance, Brandt et al. Published a study on the first 7 wind farms, and actually they show displacement on average by an SEL of 143 dB SEL. So that fits pretty well, actually, with the German guidance. Then Jakob Tugart and I published a paper about how we could actually judge the mitigation efficiency of different noise mitigation measures. And this is implemented here. We do have some more guidance on how noise abatement can be put into a larger perspective by Nathan Merchant, for instance, that was going on. And then Tobias Schaffel published a paper that seal scarrows may even induce TTS. So this is important to know in terms of nature conservation. It is clear that there is a difference between injury and disturbance. And in that case, there is an interaction, and that interaction is also given for pile driving itself. You may have injury in close vicinity, you may have disturbance in larger vicinity, and that may change and interact with each other. And other countries in the meantime have actually followed the German example and setting other thresholds and different methodologies in place. But I think in general, the guidance that Germany has given was pretty good. So this gives a potentially positive perspective for the German North Sea, as we have all of these different things in place. And we could term that a best practice example. So the take-home message from the presentation is pretty much that the final scientific judgment should not inhibit conservation measures. You can do that if you have the first scientific evidence that something is going on and that it potentially has adverse effects. The German approach can be termed a best practice example because it is the precautionary approach. It was immediately introduced after first scientific findings. It is very simple. And it is balancing different needs, like offshore wind farm constructors, as well as conservation efforts in that term. It facilitated technological advancements from the idea to the state of the art, which is also very important. It's very important to realize that not everything can be done by nature conservationists, and engineers do their job quite well as well. There's always the need for further evaluation based on newer scientific findings, and that should be implemented. But it is also important to realize that there is a consistency matter there. So if you don't abide by your values for a longer time frame, then they become useless. So working in a museum, I also have to do a little advertisement section. So we do yearly topics, and the last 2 years we had no noisy sea as a topic at the Meeres Museum. We have hung a 7-meter long orca that was tattooed with noise symbols to make people aware of what is going on in the sea and to actually transport that matter to them. At the moment, we have also produced an underwater noise movie about causes, effects, and solutions, which you can see under that YouTube address. And we have installed an animal audiogram database that you may find useful for your own research. And at last, I would like to ask you to stay tuned because we are starting to do a mixer for underwater sound so that people can actually listen to the sounds and see what they are like if they are overlaid with animal sounds. And I think this is a pretty good thing to use for public relations. And with that, I would like to thank you. I must say that especially the legislative stuff was done by other people, not me. And I think those are critical also in doing these processes. Thank you.
Thank you very much, Michael, for such great presentation and for bringing us this concept, or reminding all of us the concept of precautionary approach linked with conservation and supported by science. I will now give a minute for people to choose the questions on the Q&A option. And we have already quite a few questions, so I'll give a bit more time for you all to vote, and then we can start asking these questions to Michael and get his knowledgeable answers. Okay, well, we already starting to have quite a well-defined priority. The questions, I'll start with the first one from Pier Antonio. Are the wind farms construction monitored? I mean, is somebody checking that they follow all the guidance and use the mitigation measures needed?
So I think that many people don't like it, but yes, they are monitored very efficiently in that case. And it's also described in the Lucke, in the standard for environmental impact assessments, how it should be done. And actually, there is a reporting necessary to the agencies within certain timeframes. So it was actually even done that some of the projects, of the wind farm projects, were stopped in between because they didn't abide the rules, and they had to think about other ways of mitigating their sound input into the environment. So yes, it is monitored, and also harbour porpoises are monitored by having seapods in the water and aerial surveys.
Thank you very much. Now from Jonas Tillman from Aarhus University. There are several types of wind farms foundations. Do you think that monopiles use double bubble curtains will be the best choice for foundations in this future, given that the construction period is relatively short?
I think this is a cost-benefit analysis in the end. And in terms of the cost-benefit analysis at the moment, the monopiles are the standouts, and they will be used wherever they can be used. I think it is something about the noise mitigation. I do think there are other ways around. There is vibratory piling that can be done up to a certain depth. But there are other methods that may come up and that we don't think about, and especially the hydrosound damper that was developed, which is rather fixed air compartments within the water column, shows some very good potentials.
Thank you so much. And now a question from Fabian Ritter. Rather than mitigating loud noise, I would argue avoiding noise is even more important. Can you elaborate a bit on alternative, that is less noise intensive foundation plants?
Yeah, I think this is an excellent question because it shows other directions than just mitigating the sound. And in actually doing the research for this presentation, I was also coming by a UK paper on what the best mitigation strategy is, and they didn't even talk about bubble curtains at all. They talked about a trade-off of extra disturbance in terms of seal scarers versus longer and shorter pile driving times, and also having different energies. And I think this is the wrong direction to go. And so I strongly support that other means of putting those wind farms into the sea should be found. Those suction buckets are one way forward. There are heavy foundations which can be used in lower water depths. And then there are anchored mooring systems which are in the development. They all show some potential, but I have not seen a full wind farm being established that way. I may be misled that way, but I'm not aware of it.
Yes, definitely very important to find other ways of dealing with the issue. And now for the final question from Carl. What effect does operational noise after construction have on harbour porpoises distribution? Is it monitored?
So operational noise is actually in the frequency range pretty much up to 100 hertz, and harbour porpoises do not hear very well in these frequencies. So this question is probably better addressed if you consider harbour seals or grey seals, because they do very well here in these frequency ranges. So it is estimated from papers that porpoises may not hear the sound beyond 100 meters. And so I think the effect from the operational wind farm will be rather the ships that are necessary to transport things towards the wind farms and from the wind farms, and making maintenance on the wind farms.
Thank you very much, Michael,